Hi, my name is Aneta and this is Chemistry at Glance. If you don't know me yet, you can visit my website. I left the link in the description box below. And on this channel and on my blog, I basically share everything I learned for my AS level chemistry at school. And now I share it with you guys. Our today's topic is reactions of alkanes and alkenes and polymerization. So let's get into it. So I prepared a lot of questions for you, and if you're interested in having a copy of them, just email me, let me know somehow, leave in a comment or anything, and I'll definitely send it over to you. So this is our first question. The decomposition of hydrogen peroxide, H2O2, may involve hydroxyl radicals. State why this is described as a radical. So whenever they ask you about radicals, they want you to know that radical is an substance that has unpaired electron present. And that's exactly what's happening in this example. When hydrogen peroxide is decomposed, it will create hydroxyl radicals, which look like this. And that dot tells you that we have an unpaired electron. So it's in a radical. So the answer to this question is unpaired electron present. Okay, the next bit says, another reaction that produces radicals is the reaction of chlorine with propane. Give the equation for the reaction of a propyl radical and chlorine gas. Okay, so first of all, propane, which means we have 3 carbons, and it's an alkane. So our general equation for alkanes is CnH2n plus 2. So this is the molecular formula for our propane. When we have our propyl radical reacting with chlorine gas, propyl radical is missing 1 hydrogen. And if it's missing that 1 hydrogen, it has 1 unpaired electron. So we know it's a radical, so we want 1 unpaired electron. That's why we have 1 less hydrogen. And now it's reacting with chlorine gas, which is just Cl2. And it will give us C3H7Cl plus Cl radical. As you can probably see, this is a propagation reaction, our chain reaction. If you don't know what I'm talking about, visit my blog. I left the link in the description box below for this topic, and you can know what I mean by initiation, propagation, and termination. They are all stages of halogenation. Okay, so the next part says, why is the reaction in I described as a propagation reaction? So this is because in propagation reaction, we use one radical and we create a different radical from this. And this goes on and on and on as a chain reaction. So I wrote radical is used, another radical is formed, and so on. This is also called a chain reaction because you're basically going to have 1 chlorine molecule radical, then react it with another propane, which will give you again this propyl radical reacting with chlorine gas and forming a chlorine radical, which will again react with propane, and so on and so on. Okay, so radicals are involved in the cracking in an alkane of molar mass 100 grams. Deduce the molecular formula of this alkane. Okay, so we know it's an alkane, and we also know that it has an MR of 100. So what you want to do is just divide 100 by 12, which gives you 96. 12 because this is the AR, atomic mass, of carbon. And we know alkanes consist of carbons and hydrogens. However, if we have, I looked at my notes and I completely ignored the calculation itself. So 100 divided by 12 is 8. However, it's actually 8 point something. So if we have like 8 carbons and each carbon has an AR of 12, this will give you 96. And our molecular mass of this alkane is 100. So we're not going to have enough hydrogens. We're only going to have 4 hydrogens. So we can't actually have 8 carbons with just 4 hydrogens. There has to be less carbons and more hydrogens. So what you do is, okay, so 8 is not a good number because we're not going to have enough hydrogens. Let's try 7. 7 times 12 equals 84. 100 minus 84 gives us 16. So we have 16 hydrogens because each hydrogen has an AR of 1. So let's imagine we have 1, 2, 3, 4, 5, 6, 7. 7 carbons. So how many hydrogens would we need? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And that's exactly what we are left with. So we know 7 carbons. We have 16 hydrogens. 7 carbons, which is 7 times 12, plus 16 hydrogens gives us 100. So that's how you know that the alkane we're looking for is C7H16. And the next question, next part of this question. Radicals are produced by the homolytic fission of covalent bond. What is meant by a homolytic bond fission? So fission means that a bond is broken. So it breaks apart. And now we have 2 types of bond fissions. One is homolytic and one is heterolytic. Homolytic is the one that when a bond breaks, each atom gets 1 electron. So the electrons are shared equally. Heterolytic is the one where one atom gets all the electrons and the other atom doesn't get anything. So it gets a very, very small amount. So they're not shared equally. But homolytic, which is the one we're looking for, means that when a bond breaks, electrons are shared equally. There are a lot of things which may be confusing at this stage if you're not fully understanding the topic. So I really encourage you looking at my blog first and going through all the topics. I include examples there as well, and then come back and see the video. But if you're okay with the topic, let's get on to the next question. So petroleum is a mixture of saturated hydrocarbons, some of which are structural isomers of one another. These are separated into fractions by distillation. Some of these fractions are used to make important chemicals such as ethene, while others are used to make fuels. Explain what is meant by a saturated hydrocarbon. So, we have 2 types of hydrocarbons. One of them is saturated, which has this bond, and the next one is unsaturated, which has this bond. So unsaturated are alkenes, saturated are alkanes. But they both hydrocarbons, so they both only have carbons and hydrogen. So now, what is meant by a saturated hydrocarbon? So this is a molecule which only contains carbon and hydrogen, and saturated means it has a single bond. So it won't accept any more atoms to it. So a carbon-carbon double bond can open the bond and accept another atom. However, saturated hydrocarbon cannot do this. So saturated hydrocarbon, is a compound which only contains carbon and hydrogen and can't accept any more atoms. Okay, so next part says propane and heptane are two of the hydrocarbons obtained from petroleum. Write the equation for the complete combustion of propane. So, we also have two types of combustions. One is complete, so enough oxygen is provided and carbon dioxide is formed, and the other one is incomplete combustion, and then in that one not enough oxygen is provided, which causes carbon monoxide to be formed. In this example we have a complete combustion, so we have enough oxygen, and our equation for this would be propane, and as I told you, in combustion we mix propane with oxygen, which will give us carbon dioxide and water. So this is the general equation for complete combustion. We have a product reacted with oxygen, and carbon dioxide and hydrogen and water are formed. In incomplete combustion you would put product plus oxygen, you'll have carbon monoxide plus water. But now we are focusing on complete combustion. And last thing that you gotta do is just balance the equation. And this is the balanced equation. If you're not sure how to balance equations, I invite you to my previous videos or my previous blogs on my website, where I explain exactly how you balance equations. I will leave the links in the description box below for balancing equations for you. So next part says 3-ethyl pentane is a structural isomer of heptanes. Draw the skeletal formula of this isomer. So what I usually do is draw it out first. So we have to draw 3-ethyl pentane. Pentane suggests we have 5 carbons, 3 ethyl from either side. It's going to be in the middle anyways. And it's C2H5. This is our ethyl group. And then just hydrogens. I'm not going to write them all down, but they all hydrogens around. So now what you do is draw the skeletal formula. So we have 5 carbons. So 1, 2, 3, 4, 5. And now where our ethyl group is, 1, 2, 3, you just draw 2 lines, which shows you another carbon and another carbon. And this is all we gotta do for this one. Next part says, describe the structure and bonding in an ethene molecule. So let's draw out our ethene molecule. We have hydrogens and a double bond. So in the exam, you can draw this and just write they are the 2p orbitals, and that will give you a mark. And then when you draw that, you also want to draw this and name it pi bond. So what I did here is showed you a pi bond, and this pi bond is formed when 2p orbitals overlap sideways. In an ethene molecule, 2p orbitals overlap sideways, creating a pi bond. Pi bond, this part is very, very electronegative. So it will attract all these positive ions to itself. But apart from our pi bond between carbon and carbon double bond, we also have a sigma bond between our carbon and hydrogen. And this is all you gotta know for bonding in ethene. Ethene can be used as a starting material in the industrial preparation of ethanol, but ethanol can also be made by the fermentation of glucose, and this is the equation for the fermentation. Calculate the minimum mass of glucose required to give 230 grams of ethanol. So, in this question, you have to use this equation, N equals M over Mr. So we know the ethanol, we have 230 grams of ethanol. So we know the mass, we know the Mr because we can calculate it, so we can find number of moles, which we then use to find the mass of glucose. So N equals M over Mr, our mass is 230 grams, and the M of ethanol is 46. You just add up all the ARs to find the Mr of the whole compound. And this gives you 5 moles. As you can see, we have a 2 in front of this ethanol, which means glucose and ethanol are in ratio 1 to 2. So for every 1 molecule of glucose, we have 2 molecules of ethanol. So if you find 5 moles of ethanol, we have to divide it by 2 to find the number of moles of glucose, which is 2.5. Now we use this number of moles of glucose plus the Mr of glucose, which is 180 if you add up all these ARs. So you just want to find the mass. Rearranging the equation, 2.5, we times it by the Mr, and we're left with 450 grams. This is the amount of glucose that has to be used to prepare 230 grams of ethanol. Our next question is, explain the meaning of the term homolytic fission. So this is again the same. So in a homolytic fission, a bond breaks and each atom gets 1 electron. Basically, the electrons are shared equally. So the more you practice it, the quicker you will remember it. Okay, next part says, state the conditions under which the chlorination of methane takes place. So the chlorination, which is also called halogenation, is that process that I told you about earlier in this video, the initiation, propagation, and termination. So the conditions for halogenation or chlorination are UV light. Without our UV light, the radicals, the chlorine radical wouldn't be formed. Okay, so the next part says, show the mechanism for the chlorination of methane to form CH3Cl. So this is all the steps. So the first step is the initiation. And during initiation, we change our chlorine molecule into a chlorine radical. But remember, the equation has to be balanced. We had Cl2, so 2 Cl radicals. And of course, you need UV light. The next part is the propagation. This is the chain reaction part. So we are working with methane, and methane is CH4. So what I told you before was, you have your product, you mix it with a radical. This gives you another radical, it lost 1 hydrogen to have a unpaired electron, and something without the radical. So our chlorine and that one hydrogen which we just took from methane. The next part of propagation is that you use this radical that you formed, mix it with chlorine gas, which will give you a CH3Cl, so we no longer have that fourth hydrogen but Cl instead, and you have to have a radical in each of these equations, so we end up with chlorine. This chlorine is then again used, and so on, so on, so on. That's why it's a chain reaction. Our last part is the termination. During terminations, two radicals combine together, forming a non-radical. So in this example, we have our CH3 radical, and the other radical that we had is Cl radical. They both combine together to form CH3Cl, and it's no longer radical. They both had an unpaired electron. Now the electrons are paired. So that's what we were asked to form. CH3Cl. Next question. In electrophilic addition of HBr to propene, why is the 2-bromopropene the major product? So in the electrophilic addition, we have our propene, and the HBr. So our propene changes to 2-bromopropane. So the hydrogen, and now we can either have one hydrogen added onto this carbon and Br on this one, or you could have Br added on this one and hydrogen on the middle one. So these are the ones that can be formed. And we are told that 2-bromopropane, which is this one, is the major product. And this is because the second carbocation is much more stable than the first one. This is because the positive charge is more spread out in 2-bromopropane than it is in 1-bromopropane. That's why this one is the major product. Second carbocation is more stable and positive charge is spread out more. Hydrogenation of alkenes. What is the catalyst and conditions used in this reaction? So, hydrogenation of alkenes is basically if you had an alkene, for example an ethene, hydrogenation would be adding the hydrogen molecule for it to be no longer an ethene but an ethane. As you can see, you had 4 hydrogens here and you have 6 hydrogens here, so 2 added. The conditions that are used are 200 degrees Celsius, 17 atomic pressure, and we need a catalyst, which is nickel. These are the conditions you have to remember. And now we're asked to write the equation for the hydrogenation of ethene. This is basically what I did up there. So you had your ethene molecule. During hydrogenation, as the name suggests, you add hydrogen. And then you no longer have this double bond. You have a single bond because it opens and accepts this hydrogen molecule. And this is your equation. Okay, so that was all I had today. Remember, everything I show you are my techniques and ways of learning and revising. If you have any questions about my videos, please comment or email me. I leave all the links in the description box below as always. Also, if you have any comments about the quality or content of my videos, please also leave them under this video. Thank you. And like, subscribe, and see you soon. Bye.